So the next thing is to understand what is a term. So algebraic expressions are made up of terms. So what are they? A term is a constant or product of constant and variables or variable. So here we have set of expressions and let's determine the number of terms, and let us write down, in some cases we can write down also what are the terms. So here we are looking at 3x plus 10. So we have two terms. 3x is one term and 10 is another term. In the second example, we are looking at again how many terms? Try to pause and figure out all the terms in all of the expression. Okay, I hope you guys have tried. So we have, in the second example, we have two terms again. One is 3 into x plus 10 and x plus 10 divided by 2. There are two terms. Let me expand both of this using your distributive property. Again, pause the video, use distributive property and expand both of this. So your answer will be 3x plus 30 plus x by 2 plus 10 by 2. Okay. At this step, how many terms are there? At this particular step, how many terms are there? There are 4 terms. If I further simplify this, 3x plus half will be 7x by 2 and 30 plus 10 by 2, that is 35, right? So here how many terms are there in this? There are 2 terms, yes. Next, we just have a constant. How many terms is there? There is a single term. Next example, 2a, 4b and negative 10. There are 3 terms. In the next example, 3x square, 4y square and 10x. Again there are 3 terms. So first step in doing any part of solution or any kind of solution that you're looking for any particular question, you need to understand, identify what's the term, and then you can start with the solution. Without identifying the terms, you can't do anything. Okay, in a term we have to understand the word coefficient. So what is a coefficient? Coefficient is a constant that we multiply with a variable or variables in a term. So here I have a term 3x and so on and so forth. Let's identify the variable and the coefficient over here, right? So now, what is the term over here? 3x. What is the variable? X. And the number which is getting multiplied with x will be a coefficient. So in this case, it's 3. I'll do the second question. Let me do the third one first. So 4x by 3. What is the constant and what is the variable over here? X, right? And what is the constant? 4 by 3. And this is being multiplied with x. So this is a coefficient. So remember, it has to be multiplied, or in divided also is one of it, but it's not about addition. So here the coefficient is not equal to 10. It's not 10. It's actually something else. So we'll discuss that. So here, what is the term? This is a single term. What is the variable? Y. Of course, it's getting squared, but the variable is y. What is the coefficient? Negative root of 10. This is the constant which is getting multiplied with y. So this is your coefficient. Next one is variable is a, and the coefficient is negative 33. So we are looking at second question and the last question. So what is the variable? P, yes. And what is the coefficient? See, the thing is, if I don't have any number, it is by default 1. Is it not? Because 1 is a multiplicative identity, which means I can multiply 1 with anything and it will give me the same answer. Because of that reason, I'm writing 1 over here. 1 into p square is p square itself, so 1 is your coefficient. And we have next one, x and y as your variable, and the coefficient is negative 1 into x into y. So the coefficient is negative 1. Okay, again, I didn't have any number, I just put 1, and along with the sign I have to consider, and we have negative 1 as your coefficient for negative xy. Okay, so this is very important. If someone asks you what is the coefficient over here, it is by default 1. And over here, for a variable a, the coefficient is negative 1. Okay, so this is very important, negative 1 and positive 1. Identifying that in such scenarios is important. Again, all this coefficient and term and everything, it will help you solve. So the next thing is like terms. The like terms are terms which with the same variables and same respective exponents. What does that mean? Well, so let's look at few examples. Identify the variables and their respective power and also the coefficient. So here I have like terms. So here the variable is x and the power is 1. Both of the variable is x and the power is 1. Because of that reason they are like terms. And the coefficient over here is 3 and the coefficient over here is negative 1. Okay, right? So again, like terms are terms with same variables and the powers have to be same. Just because the variable is same and the power are different, that does not make it a like term. Okay, same variables but different powers, that is not like term. I have few examples over here, we'll look into that as well. So next is 4 and 10. They are like terms. Simple reason being, they don't have any variable, right? That's why we are able to add and subtract 4 and 10 and such numbers. So here the variable is none, the power is 0 technically, and the coefficient technically is 4 and 10, but yeah, we call this as constant. We don't call them as coefficient. Again, it's just a name, you don't have to think too much. So next one is the variable is x clearly, and the power is 2, 2 and 2, and the coefficient with the first term is 1, 10 and negative 11. Okay, 1, 10 and negative 11 are your coefficients. So I made a note, use block method. What does that mean? See, same thing if I had to do, right? If I have to explain it some other way, or if I want to look for what is the constant and what is the coefficient and what are like terms, all I have to do is just block the number, right? Block the numbers. There is nothing over here other than 1. Block the numbers. Do they look the same now? Yes, they look the same. So they are like terms. Here, well, they do look the same. We know that it's constant, so it's like term. And here, x square, x square, x square, they are like terms. Next example I have over here, again block the numbers. See, here I had 3 plus root 10, even then all of this is right. So here we are looking at xy, xy and xy. So all of these are like terms. Okay, but let's look at the constant and the coefficient and stuff. Here the variables are x and y, and the coefficient is 4. Here the coefficient is root of 10, and here the coefficient is 3 plus root of 10. Okay, right? So what equals, yeah, next is, I think, yeah, that's good enough. So let's move on to the not like terms. Anyways, you will be using the idea of like terms in solving as well. So the idea of like terms and not like terms is used in quite a few places, and well, you need to know this. Actually, all the places, there's not quite a few places, all the places in solving part we will use, so don't worry, we'll be discussing more of it. Okay, next is not like terms. So again, quite simple, just look at the variable x and y, not like term, and here there is no variable itself. So x and no variable, not like term, y and no variable, not like term. Here is where the confusing part is for many. X square and x. Yes, it is x square, x in both the places, but the power is different. So since the powers are different, they are what? Not like terms, right? So they're not like terms, okay? The next one, AB and A. AB and A, see, it's made up of two different variables. Even though one of it is A, they're still not like terms. The next one, B, again, not like terms, just a constant, so not like term. So all of them are, they're not like terms, okay? Right, so just have a look. Let's practice finding out the coefficients. Over here the coefficient is 3, here the coefficient is, try to pause and figure it out. At least just pause for a second. If you don't want to write it on a book, just have a pause and read through and figure out what are the coefficients. So here the coefficient is negative 10. This is a constant. The coefficient here is 3, negative 1, a constant. Here the coefficient is 4, negative 10, and a constant. So main thing is, this is negative 1. The coefficient here is negative 1. When you don't have anything multiplied with a variable, by default it is 1. If it's negative, it's negative 1. If it's positive, it's positive 1. And here it is negative 10. And here it is negative 10 again. Okay? So the negative is very important. Again, you guys identify the number part everywhere. I've seen that. Everyone does that. The thing which you guys miss is negative symbol. And when it comes to 1, I've seen kids writing coefficient of x as x. Again, it's a number or a constant. A coefficient is by default a number or a constant. Okay? So keep this in mind. 9th and 10th grade, you should not be making such mistakes. So here I'm trying to make you guys use the idea of like terms and help in simplifying things. See, just identifying terms and coefficient and all of those, you might feel it's of no use. Yeah, I mean, only that it's of no use, doesn't make sense. But there is a big application, and pretty much everything about maths is identifying the terms and doing something with that. So let's start off with an example. Let's identify the terms. I have a constant and another constant over here. So these two are like terms. Let me write it down. 30 and negative 20. And let's look at this. X and x. So all of them are with constant variable x. So this is 10x plus 11x minus 14x. All these are your like terms. Now all I have to do is just add and subtract. 30 negative to 10. So how do you add and subtract over here? Forget about the variables, just look at the coefficient and do your normal addition and subtraction. So this 2 is addition, so this is 21. 14 is plus 7x, right? And write the variable. Okay, that's it. Handle the numbers, right? Add and subtract them and write the answer along with that multiply with the variable whatever is being multiplied, right? Quite simple. The next question. So here I have x square, x square, x square, these are your like terms, right? So negative 10 plus 30 are another bunch of like terms, so write it down separately. Then you have negative 10 plus 30. These steps are not required actually, but when you have such big ones, it's better to write down the like terms. But yes, these steps are not at all required. You can just add the like terms, the coefficient of the like terms in your head and write the answer. Example over here, 4 negative 3 is 1, 1 and 14 is 15, x square, negative 10, 30 is plus 20. This could have been your answer directly, right? As of now, in 9th and 10th or higher grade, you guys can write this directly. Okay? For but 8th graders and all of those, 6th graders and 7th graders, you guys need to write step by step because you're still learning. So here again, let's start off. You have negative 20, negative 10. I think I didn't miss anything. No. So negative 20, positive 10. Okay. So please try it out. Pause the video and try it out. Next we have 10x, 4x, 2x. So the power of x is 1, 1, 1. So all of them are like terms. So 10x plus 4x plus 2x. Then we have 4y square, 3y square plus 4y square plus 3y square. And now we need to simplify. So you have negative 10 plus 16x, right? You just have to add the numbers, okay? Do consider the sign, if not you will go wrong. Right, here we consider the sign and we got this answer, right? If not, I would have got 30 or negative 30 or some wrong answer. And here the answer is positive 7y square. Right? So next question. Let's write down the like terms. 3x and negative 40x. Okay? Because they are of same power and same variable. Next we have 4y and 2y plus 4y plus 2y. Then we have 2x square and 3x square plus 2x square plus 3x square. So I didn't miss any signs. If you miss the signs, then it will go wrong. So here you have to take the difference between 40 and 3. So the symbol is negative and the difference is 37 and the variable is x to the power of 1. Next variable is y and the coefficients are 4 into positive, so you'll be adding. Next is x square and the sum is 5 and we have 5x square as your answer. Is it not? Okay, but again, I don't just want to teach, I want to explain why is it so. Why is that we can add only like terms, but why not something else? Why not unlike terms? So it's like this. If I take the idea of banana and guava, right? So if x represents one banana, okay, that's a banana. Let me use yellow color. Yeah. And this represents 3 bananas, right? So in total, how many bananas do you have? 4 bananas. And this is guava. So green, 1 guava and 2 guavas. So in total, you have 4 of the bananas and 3 guava. Is it not? 4 bananas and 3 guava. And you cannot tell like in total I have 7 banana guava. There's no such thing, right? Banana and guava is altogether different. So you can X and Y represents different things. It's not only guava, count of guava and banana. It can be anything. You know, it can be number of pen, in a class and all that. Whatever questions you guys come across in your textbooks. X can be the number of pen and Y can be the number of eraser found in two different places, the count and stuff like that throughout the house. So this was the first pen found, and in a box they found 3 pen, and they found an eraser and 2 erasers somewhere else, and it's a 2 different quantity altogether. Physically it represents 2 different things. But yes, end of it, if physically they represent same thing, or you're just counting the number of fruits, then yes, you're looking at 7. Right? If you substitute particular number and so on and so forth, and you want a numerical answer, it depends on the situation. But as a whole, X and Y represents different things. So you cannot add them. It's as simple as that. The next one, x square, 10x square, 4x. See, x represents a single dimensional quantity. X square represents x into x, a 2-dimensional quantity. And 10x square also represents 2-dimensional quantity, and this is single dimension quantity. So see, if I ask you to add, say this is single dimension is length and 2 dimension is area. This is also area and this is length. Will you ever add length and area? You can multiply length and area, but you cannot add them. Is it not? It's not practical, right? How can you just add length and area? You can't add length and area. Of course, you can multiply length and area, that will give you volume, but you cannot add length and area. So that's why, even though the variables might talk about same thing like length, length and breadth and stuff like that, right? Like square, length of a square, and this is area of a square, and this entire term is area of square. So you cannot add them. But of course, again, if you substitute values, and different scenarios will lead to different things. So as of now, I'm talking at a stage wherein you have variables, why we can't add them. Post substituting the number and so on and so forth, that's a different story altogether. And why is that at the first place are we adding this? Again, I'm just talking about why we can't add stuff and not beyond this. I am not trying to talk about anything else. Just why not? Why should we not? Right? Two simple reason. If you have 2 different variables, they are, or they might be, or they will be representing 2 different things altogether. But if you have same variable but different power, they are in different dimension, right? So different dimension, we cannot add them. But yes, you can multiply different dimensional quantities, and you can multiply different variables. So multiplication is another thing altogether, addition is another thing altogether, right? So that's why you cannot basically add variables which are with 2 different letters, and you cannot add same variable but 2 different powers. Okay, I hope some sense of why we should not add or subtract unlike terms made sense to you guys. And yes, simplifying and all of this is very important. Okay, and using distributive property and everything is till now is very important. This is the last stage of basics. So post this, you'll be shutting off with your syllabus. If you're done with all of it, you're going to be really good with your maths. I'm telling you, because I've seen it. These are the things which kids make a mistake, and syllabus wise they'll learn. You guys are smart enough. I'm confident of that. Right. So let's see you in the next section.